Hello everyone, this is Doug Fowler speaking. Today I would like to demonstrate the SysTune SSA filter. SSA stands for Spectrally Selective Accumulation, and it gives us a powerful method for keeping noise out of our measurements. As always, the first thing we need to do is establish our FFT size. Today I have chosen an FFT length of 1.37 seconds, giving us a frequency resolution of about 3/4 of a hertz. I have set the SysTune generator for the same FFT size, and I am using 1/6 octave smoothing to get rid of some of the unnecessary detail in the measurement, particularly in the high end. The next thing we need to do is establish our channel offset time by using the SysTune real-time impulse response display. Today I will use auto mode for demonstration purposes. When I push the auto button, SysTune will lock onto the peak of the impulse response and insert that value as the delay offset between the measurement and reference channels. This is a very useful feature when you need to work in a hurry and will be moving your measurement microphone quite a bit. Let's do that now. I took SysTune out of auto mode and left the offset in place. You could leave auto engaged if you wish to. So we have our offset, and now I would like to store an overlay of the measured magnitude response of the loudspeaker so we have a reference to look at later. I will capture the measurement, change the color, and rename it. Okay, the next thing I will do is change the top display from impulse response to the spectrum display. You will be able to see the difference between a non-SSA measurement and a measurement which uses the SSA filters. When the SSA filter stages are set correctly, we will not see the contamination which I will introduce into the live measurement peeking out from under the stored measurement. When the SSA filter is not in play, the noise and contamination will be clearly visible. Measurement contamination. Today I will use 4 methods to do this. The first 2 will simulate a noisy stage environment, such as backline techs preparing for a show while you are attempting to measure. I'll play an electric guitar track and a drum track, both from Alan Parsons' Soundcheck 2 CD, and you should hear them clearly in the background in the measurement signal. The other 2 methods I'll use today will be voices and hand claps. So we have our delay time, and we've stored an overlay for future reference. Let's look at the SSA settings. Below the Tools tab lies the SSA filter section. The filter works in 3 stages. The first stage, which must be engaged to use the other 2 stages, is a signal threshold. Any data below this threshold will be excluded from the measurement. This comparison is done in the frequency domain individually for each frequency. So to pick a threshold, there are 2 methods. If you are measuring at a relatively low level and background noise such as ventilation or people talking is an issue, measure the noise floor and add 6 to 12 dB to set the threshold above the background noise. If you're measuring at a higher level, such as at a venue while show production is occurring, use the RMS average level you intend to measure at and subtract 6 to 12 dB or more from that level for the signal threshold level. These numbers are not absolute, but will give you a good starting point. You will need to tweak this occasionally. The second step is an excursion filter, which compares the last measurement to existing data. If the measurement changes too much, it will be included with either small weighting or not included at all. How much deviation is allowed depends on the setting of the excursion filter. It could be small, medium, or large deviation allowed before the data is excluded from the measurement. The third step is a coherence filter, which excludes data from the measurement if it is uncorrelated or incoherent. The low, medium, and high settings define how well the data must be correlated to be included in the measurement. A high setting here would require data to be very coherent. So we are set up for our measurement and we have examined the SSA filter settings. We are measuring at about minus 32 dB RMS, and that's dB full scale. We are also using only one average and have set the SSA filter threshold for minus 44. Excursion filter for a small tolerance, and coherence filter requiring high coherence to be included in this measurement. Very important, notice only one average here. Normally, we use a high number of averages to push the invalid data down further into the measurement, but that data is in the measurement to begin with. The SSA filter keeps this data out of the measurement. It's a very important distinction between using the SSA filter and using a high number of averages. Once you have the SSA filter set, you can further improve the validity of your measurement by increasing the number of averages, but for the purposes of this demonstration, we're going to use one average and show you how well it works. The first example will be electric guitar. Before we start the demonstration, I'm going to change the display axis on the spectrum mode up here so that you can see the guitar contamination peeking out from underneath our stored measurement up here. So let me zoom in on that like so. Okay. Now we're going to start the analysis and start the guitar track with the SSA filter engaged. Okay, filter off, watch what happens. Okay, let's try it with a drum kit. Start analysis, start the drums. The next example will be voice contamination, and I'm using the spoken word track from Alan Parsons' Soundcheck 2 CD. In fact, that's Alan Parsons you'll hear speaking in the background. So let's start the analysis. I'll start the vocal track, SSA filter is in, then I'll switch it out and we can see the difference.
Soundcheck definitive audio testers and practical material filed as a result of careful research and investigation made by studio engineers, technicians, serious audio files, record producers, and musicians. Soundcheck is a definitive audio testers and practical material filed as a result of careful research and investigation made by studio engineers, technicians, serious audio files, record producers, and musicians.
And our last example will be hand claps. This could be doors slamming, it could be road case lids falling to the deck, it could be shackles falling from the ceiling from riggers that aren't paying attention, who knows. What we'll see here is that the SSA excursion filter is extremely effective at removing these temporary disturbances from the measurement. We'll start out with the SSA filter engaged, then we'll switch it off. I'll be using hand claps. So that's it. I hope this is helpful to everyone, and I hope that it unravels some of the mysteries of the SSA filter. You need to tweak it a little bit. You probably won't get it right the first time when you first start using this, but if you practice with it a little bit and begin to understand how this thing works, you can get your head around it, and it is an extremely valuable tool when you're working in noisy environments. This has been Doug Fowler, and I'll see you next time.